Hello everyone. In this video, we are going to use machine learning in order to detect if a given comment is toxic in nature or not. So in social media, we can see cases where people use abusive comments. So this model will detect and classify a particular comment, whether if it is toxic in nature or not. So in order to run this model, we'll have to begin with importing some necessary libraries. So as you can see over here, we have imported pandas. So what this library does is that it helps us to create data structures, and pandas not only creates data structures, but it also helps us to manipulate those data structures. And in the beginning, we'll have to use pandas in order to read our dataset. And then we have imported NumPy. So NumPy stands for numeric Python. So what NumPy does is that it helps us to work with arrays, and not only working with arrays, but NumPy also has domain or algebra and matrices. And then the third import over here is Seaborn. So what Seaborn does is that it is a data visualization library, and Seaborn is based on Matplotlib. So basically Seaborn helps us to visualize statistical graphs. And then we have imported Matplotlib. So Matplotlib is a Python library which helps us in plotting. And then over here we have imported something called as warnings. So what this import does is that whenever we run a machine learning model, so we might encounter some warnings. So this import will directly ignore such warnings. And then we have imported something called as RE, and RE over here stands for regular expressions. So regular expressions are special sequence of characters that help us to find and match other strings or other set of strings. And the next import over here is a natural language toolkit. So this is called as NLTK, and it helps us in it is basically a platform which will be used for building programs for text analysis. And then we have imported string, and over here you can see that we have imported something called as NLP utils. So NLP utils will help us to work with natural language processing. And then we have imported contractions. In NLP, we have to expand contractions. So contractions are nothing but words. Like, let's say we have a line called as I'll be there. So if we use contractions, the line I'll be there will be changed to I will be there. So basically we expand the contractions in such a way and remove any shortcut words, like will be there will be converted to we will be there. And then the next import over here is the stop words. So when it comes to stop words are nothing but English words which do not add much meaning to a sentence. Like they can be safely ignored uh, without sacrificing the meaning of a sentence. Words like the, is, if, are nothing but stop words. And even though we remove these words, they would not have an impact on the meaning of a sentence. And that's the reason why stop words are supposed to be removed from our data, which we'll do later. And then we have the WordNet lemmatizer. WordNet lemmatizers. Let's speak about WordNet first. So WordNet is a large, freely and publicly available lexical database for the English language, which aims to establish structured semantic relationship between words. And over here, we have used two tokenizations. One is the word tokenize, and then we have the sentence tokenize. So tokenization is nothing but a process of splitting a string or a text into a list of tokens. So basically, we have two options. We can either word tokenize or we can sentence tokenize our data. And then we have imported stemmings. We have imported stemmings like the Porter stemmer, Lancaster stemmer, and the Snowball stemmer. So what they really do is they are nothing but Python NLTK package So stemming is basically a process of reducing inflection in words to the root forms. So words like cooking are converted to cook, and words like fighting is converted to fight. So basically, they take a word and convert them to their root word. And for now, these are the necessary imports. Later, when we use machine learning, the number of imports will increase. And for now, as I told earlier, that we use pandas to read our data. So the data is in the form of CSV file. So we read CSV files using pd.read underscore CSV. And over here, train.csv is nothing but the file name. This is our data stored in a CSV format, and we have read the dataset and stored the dataset into a DF, and we have loaded the DF, and this is how our dataset looks like. So as you can see over here, we have a few columns. Among them, we have a ID column, which is basically of no use. So we'll have to drop this column. That's the first thing. And over here, you can notice that we have comment text. So these are all the comments. And over here, this indicates the nature of the comment. So if a comment is toxic in nature, then it is represented with the number 1. And if a comment is not toxic in nature, then it is represented with the value called 0. And then not only toxic, we have other columns as well, which are severe toxic. Then we have obscene, and then we have comments which are threatening in nature, and then we have insult, and then there is racial discrimination or identity hate. So these are the other columns. Now let us understand the data. So in order to understand this data, let us begin with knowing the shape of this data set. So we have used df.shape. Okay, there is no df.shape, but when we use df.shape, we get the total number of rows and columns present in our data set. So currently, you can also see that there are here we have the total number of rows and columns mentioned in our data frame. So we have 1,59,571 rows, and we have total 8 columns in our current data set. So over here, we have used df.info. So what this code does is that it shows us if there are any null values present in our data set, and at the same time df.info shows us the type of the data present in that particular column. So as you can see over here, the total number of rows, as I told earlier, was 1,59,571, and you must notice that all these values match with these values. That means there are no null values present in our data set for now. Let us say that there is a mismatch between these values and this value over here. Then it indicates that there are some missing values in that particular column. And at the same time, you can see over here that the type of the data is mentioned over here. So here we have the ID column, which is nothing but object type. And then we have the comment text. Again, this is of object type. And the remaining other columns, you can see that there are only zeros and ones present in these particular columns. And that's the reason why these columns are mentioned with integer types. So this is what df.info does. It gives us basic information about the data set. And in order to find if there are any null values, we can use another code which is called as df.isnull.sum. So this will display the total number of null values present in that particular column. So let's say ID column had 10 missing values in it. Then this code will show that ID column has 10 values which are missing. So as you can see over here, currently there are 0 null values. That means there are no null values present in our data set for now. And then what we have done is that we have taken a column toxic, and we have used value underscore counts on it. So when we do that, we can see that this code will display all the elements present in that particular column and give the count of those elements. So we had zeros and ones present in that particular column. And as you can see, there are total 1,44,277 zero, and we have 15,294 ones in that particular column. Similarly, we have checked all these columns, which are severe toxic, obscene, threat, insult, and identity hate. And as you can see over here, the column severe toxic has around 1,57,976 zeros, and we have 1,595 ones in that particular column. And in the obscene column, we have 1,51,122 zeros and 8,449 ones. So zeros means that particular comment is not toxic or obscene, whichever the column mentions, and one indicates that it is toxic in nature. And then the other thing that we have done is we have used the threat column, and in the threat column we have 1,59,093 zeros and 478 ones. One thing that we can notice here is that the dataset's target column is unbalanced, and we have to balance this target column, which we'll do down in the next codes, in the upcoming codes. And over here you can see that again in the insult column, we have 1,51,694 zeros and 7,877 ones. And in the identity hate column, we have 1,58,166 zeros and 1,405 ones. And the next thing that we'll do over here is we'll just see how our data is visualized. And over here, we have what we have done is that we have taken only numeric columns. So as you can see over here, we have object type data, but we cannot visualize this object type data, and visualization can only be done on the numeric values. So what we have done is we have used the iloc, and the iloc helps us to select a particular row or a column in that particular data set. And as you can see over here, these are the total numeric columns: toxic, severe toxic, obscene, threat, insult, and identity hate. And we have taken these columns and we have visualized these columns. We used the sentence types on the x-axis, whether it's toxic, obscene, and we have used the count of these sentence types. So as you can see over here, among all the columns, toxic is repeating, and toxic is higher compared to other uh, characteristics of a sentence or the sentence types. So after toxic, the other sentence type is obscene, and then we have insult, and then we have severe toxic, identity hate, and then in the end we have threat. So a lot of data in this particular data frame has toxic comments on top, and we can see that toxic has the highest count compared to other sentence types. And let us read that there are many toxic sentences followed by obscene sentences and very few threatening sentences, as seen above in this visualization. And the next thing that we have to do is we have to pre-process this data. So when it comes to the object types, we don't need the ID column, and then we are only left with the comment text. And as you can see over here, we can see /ns, and this data has to be cleaned. This particular column has to be cleaned, and we have to do some data pre-processing. And as you can see, we have printed the line. We have printed the 10th line over here, and this line has a lot of special characters in them, which have to be treated and removed. So in order to do that, we have imported RE, which is the regular expression, and regular expressions will help us to find characters, which helps us to find and match strings or other set of strings. So what we have done is that we have taken that particular comment text, and we have tried to remove the alphanumeric values in them. So alphanumeric characters are nothing but words which have digits attached to them. And then we have converted the text column into lowercase so that there is uniformity. And then we have split the data at /n. /n is nothing but a new line. And then we have removed the non-ASCII characters. And then we have mapped these particular comment text. And after that, we are left with a clean text where we have treated the special characters and removed those special characters. And the next thing that we have done is that we have created subset of these data sets. So as you can see over here, we have taken the ID column, the comment text column, and the toxic column and created one data frame. And then in the other data frame, we took the ID column, the comment text column, and severe toxic column. So in this way, we have created subset from these data set. So as you can see, we have used the ilog function again. And as I told earlier, we have used the log function and used the ID column, the comment text column, and the insult column. So the first two columns are common in throughout all the subsets of the data sets. The only thing that differs is the quality or sentence type. So we have created a data frame for insult along with the ID and comment. Then we have created a data frame called as the identity head data frame. So the similar approach again, we have taken the ID, comment text, and identity head. We just selected one other column instead of toxic, and in that way we have created data frames like the obscene comment data frame, which has the ID, comment text, and obscene sentence type. And in the similar way, we have created another data frame that's the threatening comment data frame, which has the ID, comment text, and threat column. And then we have created the severe toxic comment data frame, which has the ID, comment text, and severe toxic. So we had toxic and severe toxic columns. And then in the end, we have another data frame, which is the toxic data frame, which has the ID, comment text, and toxic columns. So we have basically created a subset data sets from that big data set, and we have visualized our data frame, and this is how our data frame looks like. We have the severe toxic comment data frame over here, and we have the threatening comment data frame. We have created the obscene comment data frame, which has the ID, comment text, and obscene columns. And then we have the toxic comment data frame, which has the ID, comment text, and toxic column. We have the identity head again, similar data frames, but the only target column has been changed over here. Now we have the identity head column. And then we have the insulting comment data frame. Again, we have the same ID column, comment text, and insult column. So what we have done next is that we have used word cloud, and word cloud will help us to visualize our words. So word cloud will help us to visualize words which are highly repeating in nature. And the next import over here is the PIL. PIL stands for Python Image Library. And then over here you can see that we have imported the image color generator, and then we have imported the stop words from nltk.corpus. We had already imported stop words, so we can remove that line. And what we have done here over here is that we have defined a word cloud where we have taken our data frames and their labels. And what we have done is that we have created word clouds for images with more frequently repeating words in them. So let's say we have a data frame which is the insulting comment. So we have taken all these data frames and created word clouds for all these data frames, and each word cloud image displays the most frequently repeating word in them. So we have given we have given the label is equal to 1. So we have given this is equal to 1 because wherever we have a digit 1 means that that particular comment belongs to that particular insult. So let's say we have this column. Let's say we have this data frame over here. So the 0 over here represents that this particular text is not insulting in nature. So we are only selecting those columns which have 1 in them. That means which are really insulting in nature. So we are displaying only such words which are really uh, insulting in nature. So over here we have a word cloud for severe toxic, and this is the word cloud for that particular data frame. And similarly, this is a word cloud for that obscene comment data frame. And we have created these word clouds for every particular data frame. So we had total number of 6 data frames, and we have created 6 word clouds. And let us go ahead. The next thing that we have to do is that, as we know already that the data was unbalanced, the data frame had a target column which was unbalanced. So we had to balance that particular columns. What we really have done is that we have taken a particular column and checked the total number of values present in that particular column using the value underscore counts. So what we have done over here is that, as we know, our data frame had unbalanced target column where the number of zeros were higher in number as compared to the number of ones present in that particular column. So what we have done is that we have created another data frame from that data frame where we selected an equal number of ones and zeros from that particular data. So over here you can see that we have selected 5000 ones and 5000 zeros, and then we have used the shape to see the total number of values present in that particular data frame. And over here you can see that we have 5000 values of ones and 5000 values of zero, and we have used the value underscore counts to count the number of ones and zeros again. And then what we did is that we concatenated these two values and created another data frame. So as you can see, we have this toxic comment balanced 1 and the toxic comment balanced 0, and we concatenated them and stored them in the toxic comment balanced, and we have created another data frame. And as you can see now that in this particular data frame, the number of zeros and ones are similar, and we have successfully balanced that particular target column. And we have checked it using the df dot value underscore counts, or the data frame dot value underscore counts in our case. And over here we have equal number of ones and zeros in this particular data frame, and the similar step has been repeated for the other data frames. As you can see over here in this particular data frame called as the severe toxic comment data frame, using the value underscore counts, we see that there are around 1,57,976 zeros and only 1,595 ones. So again, we have the unbalanced data set, the unbalanced data subset, and we have to balance these target columns again. So as we see that there are only 1,595 ones, we are supposed to take only 1,595 zeros as well, so that we have a balanced target column. And we have used the ilog function again, and we have only selected 1,595 ones and stored them in this severe toxic comment df underscore 1. And then we have selected 1,595 zeros, and again we have saved them in severe toxic comment df underscore 0. And once we have done that, we have concatenated these two values over here and created a separate data frame, and we have done that using the concat function. And as you can see here, we have taken the severe toxic comment df underscore 1 and severe toxic comment df underscore 0, and then we concatenated them and saved them in the severe toxic comment balanced data frame. And now we check the total number of values present in these columns using the value underscore counts. And we have 1595 ones and 1595 zeros. And this shows the type of the data present in that particular column. And over here we have the values in the form of integer types. And the same thing has been repeated for the obscene comment data frame. Again, we have used only 5000 ones and 5000 zeros. And before we do that, in order to decide a number, we can check the ones and zeros using the value underscore counts. So over here we have 1,51,122 zeros and 8,449 ones. So I've selected 5,000 ones and 5,000 zeros again, and then I've concatenated these two values and created another data frame, which is the obscene comment balanced. And as you can see, we have 5,000 ones and 5,000 zeros now. And the same process has been repeated on the threatening comment data frame. Over here, we use the df.info. I mean, we have used the df underscore value underscore counts. And we see that we have 1,59,093 zeros and 478 ones. So that's the reason why I used only 478 ones using the ilog function. And the same thing has been done for the zeros. Only 478 zeros were selected. And then again, we have done the concatenation and store these values in the threatening comment balanced. And using the value underscore counts, we can see that now we have only 478 ones and 478 zeros. Again, the same process has been repeated throughout the entire subsets that we created from that bigger data frame. And over here, we have selected 5,000 ones and 5,000 zeros, and then concatenated them again. And we have created this insulting comment balanced. And using the value underscore counts on the target column, we see that there are again 5,000 ones and 5,000 zeros. The same thing has been repeated on the identity head comment. Over here we selected 1405 ones. As you can see over here, there are only 1405 ones, and we selected only 1405 zeros as well. And then we concatenated them into identity head comment balance. And using the value underscore counts on the target column, we can see that now we have 1405 ones and 1405 zeros. The next thing that we have done over here is we have applied machine learning. And before we apply machine learning, we have to do the necessary imports. And as you can see over here, these are all our imports about the models that we are used, the models that we are going to use on this particular data frame now. And these are the evaluation metrics. So over here you can see that we have imported reprocessing. We have used this line over here from sklearn import preprocessing. So what this import does is that, so we have imported preprocessing, and from sklearn.feature selection, we have imported select from model. Apart from these imports, you can also see that we have imported train test split. So what train test split does is that it helps us to divide our data into training and testing part. And we basically split our data into two parts. One is called as the training part, on which we train our model, and then we have another part called as the testing. So it is done with the help of this import called as train test split. And after that, from model underscore selection, we have imported k-fold cross validation. So when it comes to cross validation, it is nothing but it is a resampling procedure which is used to evaluate machine learning models on a limited data sample. And the other imports over here are the evaluation metrics, which will decide how well our models are performing. So over here we have used logistic regression KNN model, multinomial Navy Bayes, Bernoulli Navy Bayes, and we have used support vector machine and random forest classifier. So all these models are going to get evaluated with the help of evaluation metrics, which is the F1 score, and the other evaluation metrics here are recall score, precision recall curve, F beta score, and we have our confusion matrix. So let us go ahead and see what F1 score is all about. So when it comes to F1 score, F1 score is a evaluation metric which will tell us how good our model is performing. And F1 score is nothing but it is a measure which tells us, which conveys the balance between precision and recall. And after that, we have recall score over here. So when it comes to recall, recall is intuitively the ability of the classifier to find all the positive samples. So when it comes to recall, the best value is 1 and the worst value is 0. And apart from these, we have another important evaluation metric, which is called as the confusion matrix. So what a confusion matrix does is that it will tell us how many predictions were classified uh, correctly, or how many predictions were classified incorrectly. So this is another evaluation metric which is very good in order to classify how well our model performs and evaluate how every model performs. And over here, the next imports, as we saw, is the ROC and AUC curve, which is called as area under curve. And these are our machine learning models. We have our first machine learning model called as the logistic regression. So logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal or ordinal interval. And the other model that we have imported is the K nearest neighbors, also called as KNN. So KNN algorithm is said to be one of the most simple classification algorithm, and it is one of the most used learning algorithms. So KNN is also called as a lazy learning algorithm, and KNN is also something called as non-parametric. So this is basically called as the lazy algorithm. We are going to use this KNN as well. And apart from these two models, we are going to use Navy Bayes model. So Navy Bayes classifiers are a collection of classification algorithms which are based on the Bayes theorem. So it is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. And then we have used a support vector machine. So support vector machines are nothing but it is called as a supervised machine learning algorithm, which can be used for both classification and regression use cases. So support vector machines perform good on classification as well as regression use cases. And however, it is highly used for classification problem. And after that, we have imported a random forest classifier. So when it comes to random forest classifier, random forest is a robust machine learning algorithm which can be used for a variety of tasks, including regression and classification. So basically, random forest classifier is a ensemble method, meaning that a random forest model is made up of a large number of small decision trees. So it is also nothing but it's a collection of small decision trees. And then we have imported count vectorizer and TF-IDF vectorizer over here. So the count vectorizer provides a simple way to both tokenize a collection of text documents and build a vocabulary of known words, and also to encode new documents using that vocabulary. And then we have the TF-IDF vectorizer, where TF-IDF is an abbreviation for the term frequency inverse document frequency. And this is a very common algorithm to transform text into meaningful representation of numbers, which is used to fit machine learning for our prediction. And then we have imported n-grams, bigrams, and trigrams. Over here in this piece of code, we have defined a function, and we have defined a data frame label, vectorizer, and n-grams. And then we have split our data into independent and dependent variables. Over here, we have used the train test split, and we have split these independent and dependent columns. And then over here, you can see that we have given a test size, which is 0.3. So what this means is that from the entire data set, around 70% of the data is going to get used for the train purpose, and 30% of the data is going to get used for the test purpose over here. So if we change the value from 0.3 to 0.2, then 80% of the data will be used for training purpose, and 20% of the data will be used for testing purpose. And over here we have given a random state as 50. So let's say among 5 people, 2 people use the same random state, then they both are going to get the same results, and the results are going to be matching. And over here we have used the count vectorizer, and we have used the count vectorizer on xtrain and xtest. And over here you can see that we have used all the machine learning models over here. Whatever we imported, like we imported the logistic regression, and then we have fit the model on xtrain, which was count vectorized, and on the y-train, and then we use the k nearest neighbors. The total number of neighbors that we have selected here is 5. And then we have fit the KNN model on xtrain, count vectorized, and y-train. And then over here we have used our Bernoulli Navy base, and then the same thing has been done. We have fit the model on xtrain, CV1, and y-train. And at the same time we have also used something called as the multinomial Navy base. Uh, then we fit the multinomial Navy base on xtrain, CB1, and y-train. We have then used the support vector machine, and over here we have fit the support vector machine on xtrain, CB1, and y-train. And over here we have the random forest model. The random forest classifier was fit on xtrain, CB1, and y-train. And over here, as you can see, we have used the F1 score as our evaluation metric. And what we have done over here is that we have used the F1 score on xtest. So basically we are going to use this F1 score to evaluate how all these models are going to perform. And F1 score is also called as F measure. And F1 score, what it does is that it conveys the balance between precision and recall. So then what we have done is we have used the F1 score and used the F1 score as a data frame, and in that data frame we have the F1 scores of all these models. Let us run this, and as you can see, we have created the F1 score for the severe toxic model or severe toxic data frame. So the F1 score for the severe toxic data frame is highest in the multinomial Navy base. So uh, it's not the multinomial Navy base, it's the support vector machine which has the higher F1 score. And for this particular data frame, which is called as the severe toxic, the support vector machine has given us the highest F1 score. And over here we have used the same data frame in order to calculate the F1 score for the obscene data frame. And as you can see over here, the logistic regression gave us a 90% F1 score. And again over here we can see that the support vector machine has performed very well as compared to logistic regression and other models. The SVM gave us a higher F1 score, and then the same data frame has been used and F1 scores have been calculated uh, for the thread data frame. And over here, uh, the random forest model has given us the higher F1 score this time. So far, SVM and random forest have given us a good F1 score. And then the same thing has been done. Another data frame has been created where F1 score has been calculated on the insult data frame. And as you can see over here, the support vector machine has performed well as compared to other models. And again, we have used the F1 score data frame on the identity hit, and over here the multinomial navy base has given us a 90% F1 score. uh, but as we can see over here, logistic regression also has performed very well. The next thing that we have done over here is that we have split our data set into dependent and independent columns. And as we are supposed to find out if a given comment is toxic in nature or not, so we have taken the toxic comment balanced data frames comment text on X, and on Y we have used the target column or toxic column, and then we have uh, split our data into X and Y, and the testing size that we have given over here is 30%, and the remaining 70% was given as the training size, and we have given a random state as 42, and whatever text we had, we have used the TF-IDF vectorizer on it, and we have given an n-gram range which is 1 comma 1, and then we have removed the stop words from the particular text. Then we have fit the model on xtrain and xtest, and the model that we have used over here is the random forest model, because random forest model will allow us to see the percentage of the text being toxic in nature or not toxic in nature, and that's the reason why we have used the random forest. The number of estimators that has been assigned to the random forest model is 100, and the random state over here is 50, and then we have fit the random forest on xtrain and ytrain, and then we have predicted the model on the x test. And in order to test the model, we have used three comments over here, uh, and in the first comment we have typed I killed an insect and ate it, and then we have transformed this particular comment, and then we have predicted the random forest model on it. And as you can see over here, the random forest model says that this particular comment has a 73% chance of being toxic. And as you can see over here, the above comment is 73% toxic. And then we have used another comment over here. Is this sentence a good one? For example, again, we have done the same thing. We have transformed this comment and then applied the random forest model on it. And as you can see over here, the and as you can see over here, this sentence has a very low value, and the value over here is 0.08, and this means that this particular sentence has a very low chance of being toxic in nature, and the comment is 0.08% toxic, which says that the particular comment is not toxic as compared to this particular sentence. And then another sentence or comment has been given over here, and over here we have given this comment called truth will prevail, and this model shows us that this particular comment is 46% toxic. So this is how a toxic comment classifier works, and we have successfully applied machine learning models, and among these machine learning models, support vector machines and the random forest model has predicted very well. And that's it for this video. Hope you like this video, and until then, have a good day and take care. And I'll see you soon in the next video.